This presentation explores how Ohm's law explains the relationship between voltage, current, and resistance through a simple LED circuit. Ohm's law describes the relationship between voltage, current, and resistance. When voltage is applied to a circuit, the current that flows depends on the resistance. If resistance increases, current decreases, and if resistance decreases, current increases. This simple equation, V equals I times R, forms the foundation for understanding how every electrical circuit behaves. Here, I've applied Ohm's law using a 9-volt battery and 4 resistors connected to separate LEDs. The voltage across each branch is the same, but the current changes because of the different resistor values. The 1 mega ohm LED is barely visible, the 10 kilo ohm is dim, and the 560 ohm is much brighter. The variable resistor lets the brightness fade smoothly, showing how reducing resistance increases the current and light intensity. This simple circuit demonstrates Ohm's law in a visual way. Current rises as resistance falls. With the potentiometer at minimum, total resistance drops to around 15 ohms. Ohm's law predicts about 600 milliamps of current, nearly 30 times higher than the LED's safe limit. As soon as the battery is connected, there's a bright flash from the inrush of current, then the LED dims as its junction is damaged. We zoom in to see the faint, unstable light from the partially failed LED before it finally burns out. This demonstrates how too little resistance allows excessive current and leads to component failure. Every outcome in this experiment follows Ohm's law. The dim, bright, and failed LEDs each behaved exactly as V equals I times R predicts. Changing resistance changed current flow and brightness, and when resistance dropped too low, the LED failed. This simple relationship explains every result in the circuit. Ohm's law defines a relationship between voltage, current, and resistance. It allows us to predict and control current in any electrical circuit. This experiment showed that increasing resistance reduces current, while lowering resistance increases it, sometimes to the point of failure. Understanding this simple equation V equals I times R is fundamental to safe and effective circuit design.